All right, today we're going to cover forms of energy and our different transformations between the different forms. So, we already talked about how we have kinetic energy and potential energy. Potential, stored energy, kinetic, energy of motion. So, we also have these different forms of energy that can be divided into these two big categories. You'll notice that some of these, like gravitational potential, elastic potential, chemical, and nuclear, are all types of potential energy because they're stored. Whereas thermal, electrical, sound, and light energy are all types of kinetic energy because they are energy of motion. So, we're going to go through the different forms and learn some key words of how to remember them. And then we're going to talk about how these different forms transfer from one to the other. So, the first form of energy we're going to look at is called mechanical energy. And mechanical energy is really a combination of potential and kinetic. So, that's why you see potential plus kinetic energy here. We like to think of mechanical energy as either muscle or motor energy. If it's using a motor or if you're using muscles, then you're going to have mechanical energy. So, what we're going to talk about is how you can identify different objects with each of these energy forms. So, if you see something that has like a propeller, like a fan blade, or a propeller, a motor, a turbine, that's going to have mechanical energy. If you see something that's using muscles, whether it's a human, a dog, a cat, a frog, anything that's using muscles is also mechanical energy. Then we have chemical energy, which is a type of potential energy. Chemical energy is stored in bonds between atoms, and this is where we get our energy from food. So, food or fuel or plants all have this chemical potential energy that's stored in the bonds between these atoms. So, examples would be food, plants, you might not eat them, but something eats a plant. Match tips, batteries have battery acid in them, that's chemical. Gasoline, that's a chemical. So anything that has chemicals in it is going to have chemical potential, stored energy that's in atoms. Our last type of stored energy is called nuclear energy. And nuclear energy is stored in the nucleus of an atom. This type is the granddaddy of all energies. In other words, we're not really going to be dealing with this one unless we're talking about the sun. Nuclear energy is found literally in the nucleus of an atom when we split it, like in the sun or in a nuclear power plant. We have two ways for nuclear energy to be released, and that's called fission, which is split apart, or fusion when the nuclei join together. Again, we're not really going to be dealing too much with nuclear energy unless you're dealing with the sun. Then we have electrical energy. Electrical energy is now a type of kinetic energy because it is motion. So, electrical energy is the movement of electrons. So, if it uses electricity, it has electrical energy. So this would be anything that gets plugged into an outlet or that uses a battery. Anything that uses electricity is going to use electrical energy, the movement of electrons. Radiant is also known as light or electromagnetic energy. Most of the time, you're going to see it as light or electromagnetic. You won't really see it as radiant. This is also a kinetic energy because it deals with the motion of electromagnetic waves, which are just light waves. So, our light waves include visible light, which is what we see, but also X rays and radio waves and gamma rays and all the other electromagnetic waves on the electromagnetic spectrum, which we'll get into later. But if it's going to produce a light, like a light bulb, the sun, a fire, it will have this light energy because it's producing light, radiant. Sound energy is also kinetic energy because it is a vibrational movement through sound waves. So these vibrations are going to cause a sound, and that sound has sound energy. So if it makes a noise, it has sound energy. The only place that sound energy does not occur is in space because sound cannot travel in space. And then the last type of energy that we're going to talk about, and we'll spend more time on our next PowerPoint, is thermal energy. Thermal energy is heat. So everything has these particles, and these particles are going to be in constant random motion, and that's what gives everything a temperature, a heat. So everything is going to have some thermal energy involved in it. So even things that are cold, like an ice cube or an iceberg, does have thermal energy because they do have particles that are in motion. but we think of this as heat. Okay? Now, the main thing that we use these energies for is talking about energy transformations, going from one form into another. So, we looked at energy transformations with kinetic and potential going back and forth between the two. But now we're going to start talking about how we can take an object and transform the form of energy, like electrical energy, into another type, like light, in the terms of like a lamp. So, remember, we can always change our form, but we can't destroy it and we can't lose it. And that is because of the law of conservation of energy. That law states that we can't lose it, we can't create it, we can't destroy it, but we can change forms or transform from one object to another. Like I said earlier, is all objects are going to have thermal energy. So no matter what energy conversion you do, you're always going to lose some due to thermal energy. But we know we don't really lose it, it just gets transferred into heat. So when we do energy transformations, we're going to be doing what's called a single energy transformation. And what that means is we're going from one form of energy that gets turned into another form of energy, or one step. So we're going to see what we start with. In other words, what kind of energy does it make it work? And then what's the energy that we're going to end with? What's the main thing it does for you? So for example, this first example has a sun and it's growing a carrot. Now, carrots and all other plants require sunlight in order for them to grow because that's photosynthesis. So, the starting energy, what makes it work, is light. That light energy causes the plant to grow and it becomes a food source. And we know food source is chemical. So, anytime you're dealing with a plant, it's always going to be light to chemical, one step. Think about a stove or a microwave. They actually get plugged in, so they use electricity. When your power goes out, you can't use them. So you plug it in, and it starts with electrical energy. The main thing that these things do for us is it heats up our food. So it takes electrical energy from the outlet, and it turns it into thermal energy to cook our food. Electrical to thermal. Probably the biggest energy transformation that we need to know is people. Now, you can't do energy without having food. So when we move our muscles, we first have to eat food like chemical energy in order for us to move our muscles, which is mechanical energy. So anytime that you have somebody doing exercise, running, riding a bike, lifting weights, that's always going to be chemical to mechanical, always. Another example of chemical to mechanical would be putting gas in your car. The car has a motor, so it needs to run with mechanical energy. But the car is not going to run without gas, which is chemical. So gas is chemical, makes your motor run, which is mechanical. So you always want to think, what do I start with? How does it get its power? And what do I end with? What's the main thing it gives to me? There's also things called multiple energy transformations that is going to be more steps to it. Most of the time, we're not going to be worried about multiple step interactions. We're really just focused on the single energy transformations, one step to the next step. When you do a multiple energy transformation, it's focusing on a task. So the example here is listening to a podcast, which is what you're doing right now. What you're doing is you first had to have some sort of battery to fuel your computer. So the chemical energy that's stored in your battery is going to be transferred to electrical energy that your device is using right now. That electrical energy is also going to be transferred into sound energy because you're listening to me right now. But the device is also getting warm, so you're also generating thermal energy. So that would be a multiple step transformation because it's going through each of the types of energy that you're using in order to listen to me right now. All right, that's it for forms of energy and energy transformations.